Linear regression is one of the simplest and most common algorithms used for regression tasks. At its core, linear regression tries to find the best straight line that fits your data. For example, let's look at this data set of houses. Here we have the size of houses in square feet and the prices in dollars. If we were to plot these points on a graph, they would look like scattered dots. The goal of linear regression is to draw a straight line through these dots that captures the general trend. In other words, we are trying to model the best relationship between the size of a house and its respective house price. Once we have this relationship modeled, we can predict the price of a new house just by looking at where its size falls on the line. This linear equation is what we use to form this relationship. Let's break this equation down. Y is the prediction, the value we want to predict. In our case, the house price. X is the input. This is the data we have. We are trying to predict our Y, house price, based on our X, the size of the house. W is the weight, or the slope of the line. It tells us how important the input is. For example, how much the price goes up for every extra square foot. B is the bias. It tells us the baseline value. In other words, the baseline price of a house, even if the size was 0. Mathematically, the goal of linear regression is to find the best values for W and B. Now, how do we know how wrong a line is and which line is the best? We do this by measuring the distance between the real data points and the line. The technical term for these distances is residuals, but we can consider them as errors. Initially, we draw a random line. To see how bad the line is, we have to score it. We do this by squaring all the distances, adding them up, and then finding the average. This is called the mean squared error. A high mean squared error is bad. It means the line is far away from the dots. A low mean squared error is good. This means our predicted line is close to the dots. The end goal of linear regression is to find an equation that gives us the lowest possible mean squared error.